If we are given a differential equation and we want to find its solution, we use different techniques or methods, of course, to be able to find its solution. So we're given a differential equation, we will be looking for the solution. But what is supposed to be done if we are given the solution and we want to find the dE that it represents? Now, the reverse process of solving a differential equation is called the elimination of arbitrary constants. So what we do here, from the name itself, we eliminate arbitrary constants from the given solution for us to be able to find the differential equation that it represents. So the rule in the elimination of arbitrary constants is, or the goal in eliminating arbitrary constants is that we get a differential equation wherein it only involves the variables x, y, and the derivative dy dx, which can later on be transformed or expressed in its differential form. So the rule in this process is that we differentiate the general solution as many times as the number of arbitrary constants. And if after all the differentiations has been made, one or more of the constants are still not eliminated, then we have to really eliminate them by performing substitution or elimination, or by using any other algebraic manipulations. So simply differentiate and then algebraic manipulation, as long as there should be no more arbitrary constants present after. So the key principles in eliminating arbitrary constants is that the number of constants or arbitrary constants helps us determine the order of differential equations. Now, why is it equal to the number of, why is the order equal to the number of constants? Because to get rid of the constants, we differentiate the given equation as many times as there are arbitrary constants. So if there is only one arbitrary constant, we differentiate once, so the order is first order. If there are two arbitrary constants, we differentiate twice, so it's a second order dE that we obtain. And if after differentiation there are still arbitrary constants, we use algebraic methods like substitution and elimination or any other algebraic manipulations to get rid or to eliminate the arbitrary constants. So we are going to be solving different examples to show us the different ways of eliminating arbitrary constants. So first we have the example y equals c sub 1. We are given the relation y equals c sub 1x plus c sub 2x squared. So the first thing that we have to do is to determine the number of arbitrary constants. So here we have c sub 1 and c sub 2. We have two arbitrary constants, meaning we have to differentiate twice. So we can just go differentiate directly. Y equals c sub 1, y prime equals c sub 1 rather, plus 2 c sub 2 x. And differentiating again, y double prime is equal to 2c sub 2, which is c sub 2 can be expressed as y double prime over 2. Now, even after the second differentiation, we still have a constant, right? So, if there is still a constant, we perform algebraic manipulation. So, I express c sub 2 here in terms of y double prime over 2 so that we can substitute it either in this equation right here, in the original one, or in the first derivative. So let's just name the first equation as equation number 1, the first derivative as 2, the second derivative as 3, and c sub 2 as 4. So first we have to eliminate c sub 2 in this equation right here, second equation, by substituting this third equation to the second one. So substituting equation 3 to equation number 2, So y prime is equal to c sub 1 plus 2c sub 2 is y double prime. Therefore, this is xy double prime. And we let that be equation number 5. But let us first express c sub 1 here in terms of y prime and xy double prime. So c sub 1 is equal to y prime minus xy double prime. And we let that be equation number 5. Okay, so we now are able to express c sub 1 in terms of the derivatives and also c sub 2. So we can now substitute these 4 and 5 to equation number 1. So 4 and 5 to equation number 1. So equation number 1 is y equals c sub 1x, but c sub 1 is equal to this one. So y prime minus xy double prime x plus 2c sub 2x squared, or c sub 2x squared, but c sub 2 is y double prime over 2. Okay, so that's y double prime over 2 times x squared. After which, okay, there is no more arbitrary constants. We can now just simplify that. So that's xy prime minus x squared y double prime plus 1/2 x squared y double prime. Multiplying this. And these are similar terms, we can combine them. So that's xy prime minus 1/2 x squared y double prime. And so we want to get rid of the fraction, multiply both sides of the equation by 2. We get 2y equals 2x y prime minus x squared y double prime. And then arrange the derivatives in decreasing order, so we transfer the terms on the left to the right. So that's x squared y double prime, transfer, minus 2xy prime plus 2y equals 0. And so that is our differential equation from the given solution. So we differentiate and perform substitution.